So hello, good afternoon, everyone, and thanks for joining us. I'm Rajesh, the marketing manager here at Vitex LLC. And today we have Michael Ko, our managing director, and he's going to walk us through the practical decisions behind 800G optical deployments, which is specifically of interest to the AI data centers. So Michael, I request you to take ahead from here.
Okay, sounds good. Thank you everybody for joining. Here in New Jersey, it's 85 degrees, so it's very, very warm. So I hope that you guys are having a good weather and having a good day. Let me share the presentation our team put together. See it? Yeah, okay, great.
Yes.
Okay, all right, so today I just want to spend maybe 20 minutes sharing some of the things we've seen ourselves and with our customers, specifically related to 800 gig optics, and mainly related to the applications for AI data center applications. See it? Getting into many details, we thought it would be nice to focus on few decision points or some of the issues that we've seen in the past. So first one is regarding obviously which type of optics that you want to use, usually related to your system and your distance. And then we'll talk about the some different popular form factors that's available in 800 gig optics. And also, as you may know, that there's a new version of 800 gig optics that try to use less DSP or no DSP at all to save power and to save cost. So we'll talk about some of the trade-offs that you could use for that type of optics. And then, of course, these optics need to be connected to particular cables and connectors. So we'll also highlight some of the things. And lastly, all of these things obviously has to be tied into getting actual part. So we'll share some of the our thoughts on sourcing these optics. Feel free to stop me with any questions and any comments. I definitely want it to be two-way conversation. Okay, so before we go into optics, I'm sure that probably more of you are much more an expert in this space, but this is a kind of representative data center architecture. You could see the optics has developed from, based on 50 gig SerDes, 100 gig shooter to deserializer, and now that people are looking into even 200 gig, and that will allow 1.6T or even beyond. But today we're just gonna focus on in the middle part, which has to do with mainly 800 gig, but also this applies to 400 gig, and most of these optics are based on the 100 gig serializer or deserializer technology. Okay. So the first point that we wanted to make was, probably one of the most important factors our customers need to look at is what type of a reach or distance you need to cover. So I know that some of you are already familiar with cables. So in the shorter distance, the DEC or AEC, and I'll talk a little bit about what these acronyms mean and how they're used. But these short distance typically gets covered by various type of cables. And then you have a short reach optics that can cover up to 50 meters or even 100 meters. And then you go up to 500 meter. And a lot of data center customers are starting to use DR8. That's a very popular choice because it really, these data centers are very huge, and some of the connections do require a few 100-meter connections. So DR8 is an ideal choice for that type of applications. Then beyond that, we have an FR4 and even longer distance products between data centers or even the longer distance applications. So it's kind of obvious, but it's important to note that what are the options available and what are the different cables and transceivers available for different reach. So we thought it would be useful to put together a quick reference chart. So I want to thank our product team and marketing team. It's not I wouldn't say this is 100% comprehensive, but it highlights some of the most popular features. So for example, like in-rack, which is a relatively shorter distance, which is the top row, as we talked about, usually the cables get used, and the reach is for this type of a cable 7 meters or less, and many of them do use copper cable for cost reasons, and the OSFP connector, the power is typically a little bit less than transceivers, of course. So you can use this as a kind of handy reference on the application and different optics and what are the key features of these optics. So as I mentioned that it'll be just good to touch upon some of the terminology on different cables. Let's first talk about the one in the middle. Oops, sorry about that. One in the middle, which is the direct attached copper cable. That'll be the shortest, but however, that's the based on copper cable. It's a very simple, but it's effective, especially when you have, I would say, 3 meters or less. That cable will be doing a great job. However, there are cases where you need to go a little bit beyond 3 meters, maybe 5, 6, 7. In the case that industry players are starting to use what's called AEC. So I would say the AEC is something between the DAC and AOC. And AOC in this case is active optical cable. So it's almost having a full-blown short reach transceivers at each end of the cable. So in AOC case, you can go up to, typically I would say 50 meters is safe, but some of the AOCs I've seen can go up to 100 meters. So AEC is by having a simple electrical amplifier or chips inside to boost your signal. So AEC can probably reach up to about 7 meters for a lot of 800 gig applications. So in terms of a reach, I would say DAC, and after that AEC, and after that AOC. That would be kind of a quick, handy comparison, the table that you can remember. The second point, and some of the things also I still get, and I still have to look up some of these myself. There are a few different form factors, as you are aware. The main form factors that's popular currently is OSFP, and the other one is QSFP-DD. So the QSFP-DD we shown all the way to the right. Even on the OSFP, there are a few different versions, depending on whether you have an integrated heatsink or not. So for example, IHS, that just means that you have an integrated heatsink. And of course, physically, they are taller than what's called RHS. And that just means, it doesn't have an integrated heatsink. So you have that this type of module has to rely on the heat dissipation or cooling inside the switches. Typically, we see that the lot of OSFP IHS modules get used on the NIC side, the network interface card side. A lot of switches, advanced switches, do have cooling mechanisms already. So many of them do accept more RHS form factor. I just want to obvious difference is that because they are physically different, you cannot interchange them, even though it's under the same umbrella of OSFP. So you just want to make sure that the which configuration or which optical module needs to be used with your switches and within your architecture. So on the right side, our team put together, again, the simple predominant the optics form factor that you could see in some of the NVIDIA switches or Arista switches. Okay? So the key insight is that they're physically just different, and then of course that it makes sense that you need to use the right form factor for your switches and your equipment. This is just the physical actual pictures to show you what they look like in an actual use case. So the one on the left picture, you'll see there's a fin top, and that one does have an integrated heatsink, so it's a little taller. I'm sorry that the graphics is it's not clear, but it's about 13 millimeter height. And one on the right is that's the writing heatsink, and then that one is a little lower profile at 9.5 millimeter height. So that's a physical difference you can see. Again, this is both of them is under the umbrella of OSFP, but physically they are different. These are some of the actual examples you'll see in the real life deployment. So one on the top, this will be a NVIDIA Quantum 2 QM9700 switch, and this will take what's called the twin port OSFP, and this is a most likely it'll have I think this is I want to say I don't know sure that this is RH the writing heatsink or integrated heatsink. But this particular case that you eventually gets connected to 4 different 200 gig modules, and that gets connected to different NIC cards. Another example might be that you have both InfiniBand switch at Quantum, and you have an Ethernet switch at Spectrum, and in this case that you have the twin port OSFP pin the top module that's connected, and this can get connected to a few different modules, 400 gig OSFP or 400 QSFP 112, depending on the NIC cards that you are using. Okay, so I guess the point of this graphic is that depending on the equipment, we just have to be careful, which whether you need to use an integrated heatsink conversion or the writing heatsink conversion, and even some of the breakout cables, the transfer form factor might be different because of where they get connected to, right? Here's another example of it, and this particular case is that it's a kind of a breakout case where you have one on the left, you have an 800 gig module, but essentially you can look at it as this 800 gig module contains 2 pieces of a 400 gig. That's probably the easy way to look at it. So you can make a connection to the 400 gig, 2 modules of a 400 gig optics on the right side. So here's another quick summary of a platform compatibility map that we put together. Again, depending on the switches, what they use. Yeah, just looking at the chart, I think I misspoke actually a couple slides ago. There are many cases on the NIC side, you have a writing heatsink, and on the switch side that you have typically you use the integrated heatsink version. So that's why that you want to look at the this type of compatibility map and check out the spec of various switches and NIC cards. Make sure that which optics gets used for for that particular equipment. Another interesting the consideration that we see customers make is has to do with DSP. 800 gig is so fast. Pretty much all the 800 gig optics do have to incorporate DSP to handle the signal integrity and the power because it's such a fast data rate. However, there has been some effort recently. I should say in the last, it's been already 35 years already, that people found out that you could actually have the link up and running without DSPs. So there are many different versions, but probably the 2 most common versions we've seen is, for example, linear receiver optics. So all that means is that you have a DSP only on the transmitter side. So we just call that receiver the linear optics. That's just the industry terminology we use. The other one will be linear pluggable optics. So that means that we don't have a DSP at all. So the advantages would be without using any DSPs, you save a lot of power, and also you save a lot of cost. This number is a very rough number, but roughly the DSPs account for maybe 60 to 70% of the optical module power. And then also the cost, it could be 20, 25%. So it's a substantial contributor to both your cost and your power. So obviously, if you could use the optical modules without DSPs, it's great. However, the trade-off is, as we are explaining in the slide, you really need to have a good solid link verified before. So I guess this is a way we kind of explain. So you could use that LPO, even LRO, if you have a strong built-in signal conditioning already. So some examples could be NVIDIA Spectrum 4, Quantum 2, and links are relatively short. And then your power budget is the main constraint. And you also decide to use the same, essentially same modules on both ends. And then you obviously can verify this. But if you can verify it works, and we know several customers who do use either LPOs and LROs, it does work very well. But initially, you just have to do some verification first, make sure that this type of optics do work in your application. Now, the upside, obviously, that there is always a trade-offs. For that extra effort that you made using LPOs and LROs, you do save a lot of power, which is a huge consideration for every customer that we speak to these days, because number of GPUs, and when you have GPUs, when you have so many connections, the number of connectivity requirements goes exponentially. So the power consumption is, the consideration is, how to reduce it is a big challenge. So if you could use it, obviously it's a big savings. But we just want to mention that there are some of the homework that you need to do upfront to make sure that your link is solid. Okay? Essentially, what DSP does really is that, because the DSP does a lot of signal conditioning and guarantees a signal integrity, it's much easier to use when you just put them in. So to be honest, most of the customers still use DSPs, but I would say still small, but growing share of customers are really looking into these LPOs or LROs for the certain applications. So all these different type of transceivers obviously have to be connected with the fiber cables. And this is a very simplistic overview, but the 400 gig, they normally use 8 fibers. So 4 fibers on the transmitter side, 4 fibers on the receiver side, and typically the MPO12 connectors. On the 800 gig side, because of a speed, we need to use double the fibers. So it's 8 fibers for transmitter side, 8 fibers on the receiver side. So that would be a total of 16. So typically you see either MPO16 connectors or we double the MPO12. So we call that dual MPO12. It's rare, but we've seen some cases where customers don't use the right fibers. And of course, without the right fibers, 800 gig optics is not going to work. So, we just ask our customers to double check, what type of a fiber systems are in place already, and just make sure that they are compatible with whatever optics they choose to use. So in many cases for 800 gig, we see applications where, the pure 800 gig, yes, of course, they are very common, but we probably see more common on from 400 gig devices to 800 gig, or they got switches and servers and other switches, and you just have to aggregate or separate different data rates, go back and forth between 400 gig and 800 gig. So this type of split case is very common. So starting from 800 gig to 2x400 or 4x200, or even all the way down to 8x100. So all of these are entirely possible, and suddenly we see that that's happening. And many times it comes down to, as you mentioned, the fiber cables with the right connectors on both ends. So this is some of the connectors, and you'll see some of these connectors may pop up, and this is physically what they look like. I mean, obviously this is a blown up version of the connectors. So you may see some dual CS, dual duplex LC, or dual mini LC from time to time, and so we thought it would be useful to show you what they actually look like and how they aligned. And of course, we talked about MPO16 and dual MPO12 just now, and so you'll see that there's 8 lanes for transmitter, right? And which is on the red color. Blue colors represent 8 fibers on the receiver lanes. and dual MPO12 has the twice. I mean the two connectors of MPO12. The one connector that's getting a lot of attention, and I'm sure that most of you have heard of this, which is the MMC connectors. It's a technology, I believe, developed by US Connect, and the main driver is really the density that the customers really want to put compact connectors so that they get more connection or more connectivity per given area. So MMC connectors are getting a lot of attention, and we believe that especially for 1.6T, this will be a very important connector technology. But even some of the customers are actually asking for 800 gig based on MMC connectors. Again, because they really want to increase their port density. So there are 800 gig SR8 or DR8 based on MMC connector rather than traditional MPO16 or dual MPO12. So it's relatively new, but I thought it would be important to highlight that because it's getting a lot of attention and products are coming out. So the last one is I thought that we can kind of tie all this together in terms of our sourcing. Obviously our industry customers know this much better than we know, but they're hyperscalers. They're investing tons of money in optical component industry. There are also tier one suppliers, and there are a lot of great, excellent companies. Lumentum, Coherent, Innolight, Eoptolink. There are probably I would say probably 7 or 8. They're really very large optics suppliers. And I used to work with Lumentum long time ago. And so as you probably heard, that a lot of these companies, their capacity is tied up, and the tier one suppliers are very busy supporting hyperscalers. So for a company like us, our business model is that we definitely want to work with. There are many customers who are working on very interesting technologies and exciting business model beyond just hyperscalers. So we want to work with those customers with proven optics, but also just as important, if not more important, good lead time. So we're actually carrying some stocks in our US warehouse to support these customers. And for a company like us, we don't be able to support 1 million units a year. That's not us. But if there are customers out there who needs a few hundred units or even a few thousand units in a short period, I think those are the type of customers that we'll be happy to support and work with, and hopefully we can add some value to our customers. So to summarize all different points, we believe that it's really important to whoever you work with, you sample the product first. And of course, before then, you want to verify the details, all the things we mentioned, form factor, distance. There are, we didn't go into a lot of details, but there's a CMIS, the management, a different firmware, and you want to make sure that which version that you really want and what type of connectors. And then you definitely want to work with a good partner and make sure that your overall project schedule aligns with your different components, including optics. And sometimes there actually questions come up, and maybe despite all the planning you did, despite all the testing you did, something just come up and maybe that you have an issue, then obviously that you want to make sure that you get prompt technical support from whoever you work with. And then lastly, we do have some requests from time to time from customers for TAA compliant products. And those are mainly for customers who are working on some government contracts. So we do have not everything, but we have a pretty good list of TAA compliant optics. And so we'll be happy to work with you if you have that type of requirements. So this is the recap of the kind of a common potential mistakes that you can make, depending on the form factor or fiber cable, or the trying to use something new without really testing, like LPO, or the or overqualifying some of the optics. So for example, like using DR rate for very short distance, even DR rate is really ideal for a few hundred meters. So probably it's a waste of money and power trying to use that for shorter distance connections. So these are some of the mistakes that you could definitely avoid. And just as a couple slides, just as a summary of our company, we've been in the business since 2003, and we've been based out of New Jersey. And we are relatively boutique company. So we, all of us, including myself, our key team members, have a technical background, and that's what we enjoy. So we definitely want to work with our customers. We are not perfect 100% time, but we are definitely committed to our customers 100%, and we'll do our best to support you and try to work with you to resolve any issues. And hopefully it'll be a good value and good help for your application. So this is our quick summary of our various portfolio of optics and applications, and mainly that we focus on 800 gig and a few 1.6T transceivers and active cables and also copper cables. So we work with our CM out of Asia. So these are actual pictures from our CM, and we'll be happy to share down the road if some of those customers who might be interested in getting more information. And at the end of the day, most important thing is that you want to make sure that optics works with whatever switches that you are deploying. So, of course, the NVIDIA switches are dominant currently in the data center industry. So we test the optics with several different popular NVIDIA platforms. And so that's some of the pictures that we have. And this is our contact information. So any questions you have, please feel free to contact us. And by the way, there's a Data Center World Trade Show. This is on the East Coast in Washington, D.C. next week. So if some of you plan to be at the show, please let us know. We'll be happy to meet you there in person as well. Okay. All right. Thank you very much. I'll be happy to take any questions or comments that you may have.
I have a quick question. Thank you for that. What would be the average failure rate of the field deployment you guys see from the transceiver?
Oh, okay. The AI data centers, I want to say probably, it's not really low yet, but because, when the actual failure, just to certify my question, once it's tested, the actual working, I want to say probably less than like 30%. But the typical issue will happen that when you're actually trying to test and deploy, and as I mentioned, because all these different issues may come up. So once you pass that initial testing and deployment, then usually it's very reliable. But most of the issues that's going to happen is when you try to use a new optics in the new platform, and there's always many cases there are unforeseen issues that come up. Anybody else any questions, comments? Okay, I guess some people maybe if you want to ask questions privately, obviously you have our contact information. So yeah, feel free to send us an email or give us a phone call, please. But I really appreciate your time and attention. Thank you very much.